Hi, I'm Eric. In this video, I will quickly go over some difficult part in the project one. So this video will include four components. I will talk about how to update the residential and industrial commercial and how to calculate the pollution. So do you remember in previous lecture, I talked about how to using the two-dimensional vector to read the map, read the city file, right? So actually, we have some more advanced measure to read the file, but you can still using the previous measure. So I will talk about the different way to read and change to modify the data. So because if you're using two-dimensional string, you will find that during the process, the industry or the residential and commercial will become to the number. So every time when you traverse for example, this number, you cannot figure out what this region or this region originally belonged to. So that you need to create a duplicate as a dictionary. If you want to check this element originally belong to which part, so you can directly using this one's coordinate to search in the duplicate. You will get industry, so that you know here should be a industry. So you get there's a industry zone, so that you can update the element here based on some rule in the next we define. All right. So, but you also can using the advanced way. You're using two-dimensional cell to store the all the elements of the file. You can both record the tab and the population. But first, you need to create a structure or a class, and it should be include a population and a tab. So using a two-dimension cell vector to store all the city's detail. For each cell, it will include the population and a tab. So in the next, I will talk about how to upgrade the residential. First, we need to create a copy for the current function, because we copy the grid before updating, so that all the cells are updated simultaneously. If we upgrade the original grid directly, one cell change could immediately affect the neighbors in the same step. This will break the rule. So that's why we create a copy and just change the data in the copy one. So for each cell, so we traverse all the cell of the grid. If current cell is not belong to the residential, we will not do anything because we just want to update the residential zone. So we have several measures to judge. For example, if you're using the two-dimensional string, you can just check from the duplicate data and check the coordinate row and column and find this element whether it's equal to the C. If it is equal to the C, it will trigger the judgment. Or otherwise, other way, if you're using the two-dimensional cell vector, you can also to determine the cells tab whether equal to C. If it is equal to C, you need to upgrade the current cell, right? So if the cell is not belong to residential, we will skip the current route. And then if it belong to the residential, so we will get the population over the cell. We also have some measure to get the population. If you're using two-dimensional cell, you can just access the cell's population. If you're using two-dimensional string, you need to, you can also read the data, the grids uh, with the same coordinate, and you can read the population of the grid. But 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 remember, we're using two-dimension string, so you need to transfer the data type from the string to int. You can using a system function, uh, string to int, this one, and give it the grid R and C, and so that it will become int instead of a string, so that you can use it for calculation. So you set the population is equal to the cells population. If the population is equal to 0, so because we have some rows here, if the cell has a population of 0 and adjacent to a power line, in the current time step, or just to at least one cell with a population of at least 1. So it should be increased from 0 to 1. So that means we need to give some judgment. Is this one adjacent to power line? So actually, we have a very interesting way to achieve this part. For example, if you're using the two-dimension string, you can using this code for judge. If you're using the cell, you can also using this one. So we just simplify. We're using the two-dimension cell for clarify. So if we want to check the coordinate of 7 and 4, this element, we check is this one near to the power line. We can directly call the function, give it some variable, give it a data, and the data is actually the grid. It is a map, and give the rows coordinates and the columns coordinates. So you will find that we first we retrieve the rows, the maximum of row and the maximum of column. We get the row and column from data sets, right? So we using two for loop. We loop from -1 to 1 to traverse all the column of his neighbor and all the row of his neighbor, and in the sub loop we continue to traverse all the column of his neighbor. What does this mean? We traverse from -1 to 1. So for example, for this element, its coordinate is 7 and 4, right? So let's observe its neighbor's coordinate. You will find if you using the row -1, it will become all the line up all the line in the top of the is not top in the hair of the element line. It should be this line, right? If you're using 7 minus 1, it should be 6. So we will get all the 6 line 6, right? So if the dr is equal to 0, it represents the same line over the current element. If the dr equal to 1, it represents the lower line of the current element. Also, we determine the ci from -1 to +1. So if dc equal to -1, it should be represent the left column over the elements column, right? And if equal to 0, it should represent the same column with the current element, current cell. And if the DC is equal to positive one, and will represent the right column of the current cell. So that's why we're using two for loops to traverse all the elements of the cell two's 8 neighbors, right? So if the dr and dc equal to 0, it represents the itself's coordinate, right? Because if you use it, we will calculate the neighbor's new coordinate. We will calculate new row and new column. So if the dr equal to 0, r plus 0, and c plus dc plus 0, it should equal to original coordinate. So that so we will not do anything about the the anchor cell, right? So if it's not both equal to 0, and we will calculate a new coordinate, and then we will give it the judgment to make sure the new row and new column all greater and equal than 0, at least the top left one, right? You cannot less than 0, because if you access the -1 or -1 0, it will out of the boundary, so it's not legal. So also it cannot greater than the maximum of row and the maximum of the column. So we will make sure the coordinate is inside of the boundary of all the map. So if it will if it satisfies the condition, we will read the data's the neighbor's coordinate based on the neighbor's coordinate, read the data's tab. If it's equal to the t, it represents the the power line, or equals to p also represents the power line, and then we return true. Otherwise, we return a false. So back to the pseudocode. If they're adjacent to the power line or at least one neighbor's population greater and equal than 1, based on this rule. If the population is 0 and adjacent to power line, it will increase 1. And or its population is 0 and it's adjacent to at least one neighbor's population at least 1, it will be also increase from 0 to 1. So in the next, I will talk about how to calculate the neighbor's population. So I also maybe we can just look at here. So we will find that the step is very similar with the judge the adjacent power line, right? So the only difference is here. There's 2 lines, right? And we also need to give it the threshold, because in the different step, the demand is also different. For example, if the population is 2, the only way to make it increase by 1 is that it adjacent at least 4 neighbors, and all the neighbors population at least 2. So we will set the threshold equal to 2, and set a count variable to count how many neighbors and the neighbors population is greater and equal than threshold. Okay, so we also traverse all the neighbors of the current element from -1 to 1, and here. So if the neighbors is Okay. We retrieve the neighbor's population. So we're using the get pop, give the get pop parameter the neighbor's element, a neighbor's cell, right? Because the new row and new column is represent the neighbor's coordinate so that we can retrieve the neighbor's cell. So we're using the get pop in, here. So if the neighbor's cell is R or I or C, it will return zero. In because the counter neighbor, we will call the function in the industrial and commercial and residential, so that we set if s equal to r or industry or the commercial, we will return zero. Uh, this function is based on the two-dimension string, because if you're using two-dimension string, you need to determine this part, this cell originally belong to what the region, what because you don't know the number, it represents the residential or industrial, right? So if it's not an empty and it's a number, we will return the population using the string2 int to return the population number, right? Otherwise, we return the -1. So here we will get the population over his neighbor's population. So we give it the judgment. If the population over his neighbor is greater or equal than the threshold, we set the count plus plus. So after you traversal all the neighbors over the current cell, you will calculate the situation which the neighbor's population greater or equal than threshold. So, and finally, you need to return the count. The count represents how many neighbors, how many cells with population over at least the threshold. So if you return the count in the pseudocode here, for example, if here, if at least two count, the two represents the count, at least two neighbors population greater and equal than the threshold 1. If it satisfies the condition, we will set the population growth from 1 to 2. So it's dependent on the different rows, right? So if the population, the current cells population is 2, you need to give the counter neighbors a threshold 2, and you need to judgment the count, whether the count greater and equal than the 4, because it will return a count, right? You need to judge, is this the count greater than or equal than 4? If it satisfies the condition, you can increase the population, increase the residential population, increase from 2 to 3. That's all for the updated residential part. So finally, after your traversal all the cell over the grid, you need to set the grid with the next grid with the duplicate to make sure in next step it's work. Okay, so let's continue talk about the update industrial. Actually, is very similar with the update residential because all the function is very similar, right? First, you need to copy the grid and traversal all the cell in the grid in the city. So if the cell is the industrial, then we retrieve the population. We retrieve the if you're using the two-dimensional string, you need to select from the duplicate data and make sure the number of the string, the original belong to the industry, so that you can retrieve the the population of the cell. And then if the population is equal to 0 and the worker greater equal than 2, and next to the power line, our neighbor's population greater than equal than 1, actually, it represents these two rows. If the cell has population of 0 and adjacent to power line and at least 2 workers, so it can increase by 1. Also, if the population is 0 and adjacent at least 1 cell with a population at least 1, and also you can increase by 1. So you need to first give a judgment if the pop is equal to 0 and whether the worker greater than equal than 2, and you need to determine whether the cell is close to the power line or its neighbor's count is greater and equal than 1. The 1 is the threshold. You can just call the function and give it the data parameter and give it the row and the column coordinate. Give it the threshold 1. So the function will first get the coordinate, get the maximum coordinate over row and column, and set the count equal to 0. And we will traverse all the neighbors of the cell. So if the population of his neighbor is greater than threshold, and we will plus, and finally we will return the count. So if the count here, if the count is greater and equal than 1, and it will satisfy here's condition. And if all the conditions are satisfied, and we will grow from 0 to 1. And also we need to deduct the workers number, right? And other rows is all based on the demand of the project 1, right? So the commercial is also similar with the previous function. We also need to copy and to give a judgment if it is not commercial zone. We need to break the current round, right? So we need to retrieve the population from the cell, and if the pop equal to 0 and the workers greater than equal than 1 and goods greater than equal than 1, and you also need to adjust it to the power line or the neighbor's count is greater and equal than the threshold 1. The commercial will grow to 1, and workers and goods all -1. So it's very similar with the previous. So I will not talk again. So after that, I want to talk about how to compute the pollution. Actually, I think the most difficult part in all the project. So first, we will also retrieve the maximum of row and column, and we will initiate a 0 matrix to store the pollution station, pollution state. So we traverse all the cell and set the pollution equal to 0 in the align with the coordinate. So then I will traversal all the cell from the grid, right? And if the cell is in industry, it belong to industry zone, and I will retrieve the population of the cell. So if the pop is greater than 0, so that means here, maybe here, uh, already have some industry building, maybe. So it will pollute uh, all the neighbor, and it will also generate the pollute by itself. So if the pop is not 0, it's greater than 0, and then I will set the cell pollution. For example, if for this one's pollution is 3, so I will first give it the self pollution 3, and also the other should be just copy, right? Then 1, 2, 2, 1, 2, 2, right? So the pollution will the cell pollution will look like this matrix. So uh, but we but the pollution will be made of two parts, the cell pollution and the spread pollution. For example, if here's 2, it will also affect his neighbor. This neighbor is just with 1 distant with the 2, with this element. So it should be get 1 pollution from the anchor. So it should be increase from 1 to 2, like that, right? So in the rest of code, I will let you know how to achieve this function. So first, I will set the por equal to pop. The pop is the population of the industry. For example, if I want to set the 2 is the anchor, how to change the neighbor's pollution? So first, I will set the pool equal to the 2. The 2 is the population of the industry, right? So if the pool is greater than 0, so I will traversal all the spread distance over the anchor. For example, here is 2, so I will traversal from -2 to 2, right? I will traversal all the neighbors, which is with a distance 2 from the -2 to the -2. Will traversal from the upper two line to the lower two line, and traversal the left two column to the right two column. Will traversal all the neighbors, right? And then we will calculate the neighbor's new coordinate, the new row and the new column, right? For example, for the cell 0, this one's coordinate should be 5 minus 2. It should be 3, right? And the column should be 5 plus 1, should be 6. So in this one's coordinate should be 3, 6. So then we need to upgrade the spread pollution. So first we determine the distance between this cell to this cell. So we're using a distance calculation function to just retrieve the max over the dr and dc. The dr is actually a buffer, the buffer of row and DC is a buffer over column. We retrieve the max one. Also, we're using absolute function to compare all the offset of column and row. Actually, the dr should be minus 2, right? But we're using an absolute function. It should be become the 2. And dc should be positive 1. And after we absolute, it also the 1. So compare the 2 and 1. The 2 is a max 1, right? Because 2 is greater than 1. So the distance should be 2. That is logically, right? Because uh, this cell is distance with the distance between this cell and the anchor on the column is 2. So this distance at least should be 2, right? So that's why we think the distance is 2. So if the distance is less and equal to the buffer, the pop is buffer. The maximum of the buffer actually is the population is 2. And then we set the pollution to plus the we're also using a max function. We compare a 0 and a pop to negative to deduct the distance. In here, the pop is 2 and the distance also 2. So here should be 0. So max 0, 0 also is a 0. So here should be plus 0. So that means here will not affected by the anchor. The pollution will not change. But if you traverse, if you calculate this cell, it will be affected by the anchor. At least it will increase by 1. Right? I think that's all for the pollution part. Okay, all right. That is all for today's video. And if you still have some confusion, you can email to me or just come to my office hour. And I will also post a repository as an example to you to prevent you overwhelmed by the project or to prevent you don't know how to start the project and to make sure you can complete the project 1, because for project 2 is also based on the project 1. So if you cannot complete the project 1, it's hard to start the rest of the project. Okay, so that's all for today.